So we'll be continuing with sample problem number 3. We've determined the acceleration of the skater while pushing on the boards, while coasting, and again while slowing down. So we're going to use this information to determine the displacement covered while pushing, while coasting, and while stopping. So while pushing against the boards, the question tells us that the skater has traveled 0.850 meters east. What they don't tell us is the speed with which the skater has left the boards. And that information is really important in determining the distance traveled while coasting. So in order to determine the distance traveled while coasting, we're going to have to first find out the speed with which we left the boards. Well, we know we pushed against the boards from an initial speed of 0. We just calculated our acceleration to 2.41 meters per second squared east. And we know the distance traveled is 0.850 meters. So what we need to find is V2. So we have delta D1, V1, V2, and A. What I need you to do is to look at your equations and determine which equation we can use to solve for V2. So we're going to use the equation V2 squared equals V1 squared plus 2A delta D. So V2 is equal to the square root of 0 squared plus 2 times 2.41 meters per second squared times 0.850 meters east. Punch it into your calculator and tell me what you get. .02 meters per second. The fact that it is a positive value, what does that imply? Mike?
East.
Good. That the direction of travel is east. Make sure you include that. Okay, so we know the speed with which the skater has left the boards. And we know the skater ends up coasting at this speed for 4 seconds. So we want to find the distance covered while coasting. So we know that the speed or the velocity is 2.02 meters per second east. Delta t is 4.00 seconds from the question, and we need to find delta d. So what equation can we use for this? Let's use the equation for velocity. If you rearrange it, it ends up being velocity times time. You've seen this many times in this form. You use this equation whenever you're calculating the range or the horizontal distance traveled by a projectile. So we'll use it again here. Sub and solve, we get 2.02 meters per second east times 4.00 seconds. Punch it into our calculator. And our calculator reads to 3 significant digits, 8.08 meters east. When we're determining the displacement covered while stopping, we have to keep in mind that originally, before this person was stopping, the velocity was 2.02 meters per second east. That was the speed with which it left the boards. If it's coming to rest, then V2 is going to be 0. From part A, we've determined the acceleration to be negative 0.704 meters per second squared, and we want to find the displacement. So looking at these variables that we have, v1, v2, a, and delta d, which equation are we going to use? The same one we used up above. v2 squared equals v1 squared plus 2a delta d. So rearrange this equation for delta d. Everybody take the time to do this. I'm going to pause this to make sure that you guys do it on your own. So you should end up with v2 squared minus v1 squared over 2a. From there we're going to sub and solve. v2 we said was 0. v1 we said was 2.02 meters per second. Square that, divided by 2 times negative 0.704 meters per second squared. Punch it in and tell me what we get for the third displacement here.
2.90.
Amazing. 2.90 meters east. Great. So the question initially asked us, how far did this person travel? Well, while pushing, the person traveled a displacement of 0.850 meters. While coasting, this person traveled 8.08 meters. Call this displacement 2. And finally, while coming to rest, this person traveled 2.90 meters east. If you want to find the total displacement, just add them all up. I'm going to use the plus and minus convention, plus being east and minus being west. So we have 0.850 meters plus 8.08 meters plus 2.90 meters. We're about to add these three numbers together. Some of them have 3 decimal places and the others have 2 decimal places. Make sure you report your answer to the same number of decimal places as there are in the number with the least. So report your answer to 2 decimal places. If you punch these in, what do you get? To 2 decimal places.
11.8.
One more decimal place.
3.
Yeah. So because it's positive, we assume that this is traveling to the east. So the total displacement traveled by this ice skater is 11.83 meters to the east. In sample problem number 4, we have 2 boxes that are side by side. We're applying a force onto the big box to the right. As a result, it's going to push with it the small box as well. The magnitude of the force that we apply is 160.0 newtons to the right. Now the question reads, a worker pushes 2 large boxes across the floor from rest with an applied force of 160.0 newtons right on the larger box. The boxes are touching, and the mass of the larger box is 32 kilograms, and the mass of the smaller box is 8.0 kilograms. There's a force of friction on the large box of 80 newtons to the left, and the force of friction on the smaller box is 20 newtons to the left. The first thing we should do is establish our frame of reference. Let's make left negative and right positive. Because these 2 boxes are touching And because the larger box is going to be pushing the smaller box, it's almost as if we're applying a force on the two masses combined. So it's almost as if we're doing this, a free body diagram like this, with a force of 160.0 newtons, where this is M1 plus M2. In order to answer this question, and the way we've answered every question up until now, is by doing two simple steps. First step, list all of the forces acting on the object. So in this case, we say the net force is equal to 160 newtons in the positive direction. This is the force applied. Now I need to show that there is also friction acting on these boxes. Friction from box number 1 and friction from box number 2, but I also need to show that they're acting in the opposite direction. So in order to show that they're acting in the opposite direction, what I'm going to do is make them negative. So we have minus force of friction 1 from the big box and minus force of friction 2 from the small box. The second step is to change this F net into the equation MA. So we can say MA is equal to the force applied minus the force of friction 1 minus the force of friction 2. Since we're dealing with these two masses combined, we're going to use this and say this is M1 plus M2, the combined mass of these two boxes. So if I wanted to solve this equation for A, or isolate A in this equation, what do I do to both sides? Divide both sides by M1 plus M2. Good job. So acceleration is equal to force applied minus force of friction 1 minus force of friction 2 divided by M1 plus M2. So let's sub and solve. We have 160.0 newtons minus 80 newtons, 80.0 newtons, the force of friction on box number 1, minus 20.0 newtons, the force of friction on box number 2, divided by 32 kilograms plus 8 kilograms. Everybody take the time to punch this into your calculator and tell me what you get. To two significant digits, we get 1.5 newtons per kilogram. The fact that it is a positive value implies that this is traveling to the right. So the units, as they appear in the equation, are newtons per kilogram. There's another way we can express them as well. Newtons per kilogram is equivalent to, good, meters per second squared. So you can say it's 1.5 meters per second squared to the right. If you left it as newtons per kilogram, that is perfectly acceptable. You can do both on your test. To physicists and scientists, they know that newtons per kilogram is an expression of acceleration. So over the break, as I pointed out, the answer should be to three significant digits. So it's 1.50 meters per second squared to the right, or 1.50 newtons per kilogram. Guys, you really need to be on top of that. You can't let that slip by you. In part B, we need to determine the force exerted by the larger box onto the smaller box. In order to examine this more carefully, we're going to draw a free body diagram of just this little smaller box. And we're going to examine the forces that are acting on this box. We know that the big box is pushing on it. we know the big box is pushing on it in the forward direction. So we're going to call this the force applied by the big box. And we know that friction is acting on this object, but in the backward direction. And we call this force of friction 2. Our job is to find out what the force applied by the big box is. In order to do this, we're going to have to carry over one piece of information that is crucial from the previous example. And that piece of information is the acceleration. If you know the acceleration of the entire system, you know the acceleration of all the components. So you need to be able to know that the acceleration is 1.50 meters per second squared, right? It's going to help you in finding this answer. So for this individual box, the big box is pushing it forward and friction is pushing it back. And that's how it moves. So let's follow the same two steps that we've been doing. Step number 1, list all the forces acting on the object. Net force equals force applied by big box forward minus the force of friction acting on this little box. The second step that you need to follow is to replace the expression F net with the equation for F net. So we're going to say M2A is equal to force applied by big box minus force of friction 2. So the question is asking us to find this, the force applied by the big box. So we have to get it by itself. Right now it is in this expression. In order to get it by itself, we have to shake everything else off. If we shake off this negative F force of friction 2, bring it over the equal sign. When you do, its sign will change from negative to positive. So we're left with the force applied by the big box is equal to M2A plus the force of friction 2. Let's sub and solve. M2 is 8 kilograms. Acceleration is 1.50 newtons per kilogram. And the force of friction is 20 newtons, 20.0. Punch this in and tell me what you get for the force applied by the big box. Anna, what do we get?